Hello everyone, welcome back to my channel. This is Mikushi, and today I'm going to be sharing with you guys the fifth module of Python. So let's just get into it. So it has an important concept which is exception. So you already know what exceptions are. Now exceptions occur when something in the program goes wrong. Now if there's an error, for example, I have given variable a data type, let's say string, and I've assigned it the value of a number which is, let's say, 7. So this is going to get an exception for us because it is a value error. Now this occurs, now the following code gives us a zero division error. Now as we know, dividing anything with zero is an error. So this is happening over here. Further in this tutorial, we are also going to learn about some type of exceptions which are very common. Now, this is an exception. Exception in an event that occurs due to incorrect code or input. Now, these are some different exceptions which are raised for different reasons. Now, the first one is an import error. The import error occurs when you import a method which does not exist or which is wrong, let's say. Now, in one of my videos, I have imported a re.search, which actually works out which actually is being imported from somewhere else. But sometimes if I have missed something, I have wrote the wrong name for it, then this is going to create an import error. The next we have an index error. Now, how does an index error works? Now, let's say I have a list with 1, 2, and 3 values in it, and they are indexed as 0, 1, 2, 3, 0, 1, and 2. Now, if somewhere I just ask the computer to print the seventh value, this is going to give us an error because seventh value does not exist. Next, we have the name error. So this is a known variable which is used in here. Now, if I have a variable x and a variable y in my program, and out of nowhere, I'm asking the computer to print the variable z. So that is going to give out a name error. Then we have the syntax error. Now, as we know, when we are writing something or the other in the program, that is called a syntax. Now, if some syntax is not executed properly, it's not working properly, then it's going to print a syntax error. Next up, we have the type error. The function is called on a value of inappropriate type. Now, as I've shown you, and the value error, the function is called on a value of the correct type but and with an inappropriate value. These two are interlinked and almost the same. There are even many other errors like the OS error, the zero division error as we have seen earlier. But these ones which we have seen here are the very important ones or the very common ones. Now this is going to have a type error because there is another type of value which is given here. The value which is given here is of a different type than the other one. So that is a value error, sorry, a type error. Next, we have exception handling, which is more important. So let's just see. Now, to handle exceptions and to call code, an exception occurs. Now, you can use a try and except statement when you are making an app or something like this. When an exception occurs, the user is to be informed what kind of exception has been occurred. So this is done using the try and except statement. Now, how this works, let me do it. First, we have a block of try, which is situated, let's say, here. And here we have something, let's say, print 7 divided by 0. Now, if this gives an error, now in this case, it gives an error. If this gives an error, the next block, which is the except block, is being executed. And in the except blocks, all the errors are being mentioned clearly. So the computer gets to know, the user gets to know what kind of error it is. Now here I have the same example, num1, num2, print num1 divided by num2, which is 7 divided by 0. And if it goes well, it's going to print out done calculation. But if there is an error, it's going to print an error occurred due to zero division. So that's how exception handling works. What is the output of this code? So this will be 10 by 2, which is correct. But now, as you can see here, anything which is under the except will be executed after a space. But here, as you can see, there is no space, which means that it is out of the except block. So which means that it's going to be also executed. So I have to print the result plus the finished, which is 5.0 and finished. The try statement can have multiple different except blocks to handle different exceptions. Multiple exceptions can also be put into a single except. Now here, as you can see, there are two except. One of them is a single one. Now I can use these single ones or I can use double error type. So it totally depends on you how to use what to use. Now next we'll be also seeing the one which is more better, more convenient for exception handling. 42 meaning divided by 0, and that is the meaning of life. Now except for value error or type error, there is actually no value error nor a type error. And there's another exception which is zero division. So zero division is going to occur here. Now the except statement without any exception specified will catch all the errors. Now, as we've seen earlier, we were also specifying the type of error after the except. But in a case where you don't want this to work out, you can just have an except block without any specifications so that any error occurred will be directly printed out and no particular error will be given here. And we have the number one, the number two. So this is a try. And here we have an except. Let's see the next case. The finally. Now to ensure some code runs no matter what. Now, as you can see here, this is going to end up with zero division by error. And as you know, once an error is occurred, the execution of the code stops. So what it does is this one, the code in the finally will work no matter what, no matter if there's an error, if it is not, or anything. This code will run in every and any condition. So this code is not under any other blocks. It is not going to stop its execution even if anything happens. As you can see, try printf 1. So there's no error, which means it will print 1. Then if there would be an error, then it would print 2. So it will be 1 and 3 because the finally block runs no matter what. The code in a finally statement even runs in an if an uncaught exception occurs in one of the preceding blocks. Now, leaving these, if there's an error somewhere else, then also this is going to be executed, which means that its execution never stops. So here we have okay, we need to spell. We have a try, we have an except, and we have the finally. Now, finally block is always placed at the bottom of the try and except blocks. So remembering the positions, you can have this. Raising exceptions. Sometimes we need to raise exceptions by our own. So we have the raise block, the raise statement. You need to specify the type of exception you want to raise. Now here it's a print 1. Actually, there is no value error right here, but in a case where there's a value error, this raise will have a value error even if there is not, and it's going to print out a value error. Now print 1 by 0, which is a zero division error, and a value error will be executed no matter what. So we need to have both of these. Now, exceptions can be raised with arguments that give detail about them. So you can just have invalid name and things like that so that the user gets to know what kind of error it is. Now, fill in the blanks to raise value exception error if the input is negative. If input is negative, so for any input to be negative, its value should be below 0, which is, let's say, -1 or -2 or anything as such. So we are going to have here as if float num value is less than 1, then it's going to raise a value exception error. So here we have the raise value error and it is in a negative. So that's how it works. Now, in the except blocks, the raise statement can be used without arguments to re-raise whatever exception occurred. Now, if you want to raise an exception twice, even if it has occurred just once, you need to just have the raise in the except block and it's going to do the work. You need not specify what kind of error it is because it's going to print the earlier one. So can you use a raise statement outside the except block? Yes, you can. Next up, we have assertions. So assertion is a sanity check that you can turn on and off when your program has been finished testing. An expression is tested and if the results come up false, the exception is raised. Assertions are carried out through use of the assert statement. Now, as we can see here, if this is executed, then this is executed. And if this is, then this is also going to do. But if it's false, here as we can see, there is a false. This will not be executed in this way. Now, programmers often place assertions to start off the function to check for a valid input and after the function call to check for a valid output. Now, as we can see, this will raise a true, which means that 1 will be the last number which is raised. The true one will not be raised out of here. So 1 is the highest number. Now, the assert can take the second argument that is passed to the assertion error raised if the assertion fails. If the assertions are failed, then it's going to print out colder than absolute 0. The assertion error exceptions can be called and handled like any other exception using the try and except statement. But if not handled, this type of exception will not terminate the program. So the program functioning will not stop no matter if it's an error in the assertion. Now we have to define a function, which means def, and we're going to assert x more than 0. Now next we have the opening of files. So we use a lot of files in Python and any other language. So you can use Python to read and write the contents of the files. Text files are the easiest to manipulate. Before a file can be edited, it must be opened using the open function. My file equals to open file name dot text. The argument of the open function is a path to the file. So this opens the file. Which function is used to access files? It's open. So you can specify the mode used to open the file using the second argument of the open function. Sending R means open in read mode, which is the default. Sending W means in write mode, if you want to rewrite the contents. Sending in A means to append mode if you want to add or remove something. And sending B opens it in a binary mode, which is used for non-text files, which is images, sound files, etc. You need to just specify a WR, etc. in the sideways. You can use the plus sign with each mode above to give them extra access to the file. For example, R plus opens the file for both reading and writing. So you can just do this. Drag and drop the options below to open a file called test.bin in the binary mode. It's test.bin and it is in the binary mode. It's okay, it's a binary read mode, so we need to have R and B. Sorry. Now, once a file has been opened and used, you should always close it, right? So this is done using the close method, and it's file.close. How would you choose a file stored in a variable text underscore file? So we need to just close it. Text.file close. So next up we have reading files. So the contents of a file has been opened in a text mode can be used using the read method. Content is equal to file.read. This will print all the contents of the file which is there here. So if you have this function given, then all the contents will be printed out. Now rearrange the code to read its contents, print them, and then close the file. Hold it open, content.file, read, print, and then close. To read only a certain amount of file, you can just provide a number as an argument to read the function. So here in file.read 16, it will read the first 16 lines, and in the same way in 4 and 4, and if you file.read, then it's going to read the total one. Just like passing no arguments, negative values will return the entire content. So they are just ignored if you have printed them. Now, how many characters would be in each line printed by this code? If one character is equal to 1 byte, file name.open.text.r for I in the range, which is for the lines for the bytes, print file.read 4. So here, as we can see, the I in range is 21 and the print file.read is 4. So it's going to print 4 of these characters. Now, after all the contents in a file have been read, any attempt to read further from that file will return an empty string because you're trying to read from the end of the file because it is not possible. So we have the file, open, file name text, in blanks to read its content and print it, file dot read. So, file dot. Now, as we can see, we need to read the contents and the printing of the length is already done. So we're going to have a read over here. Now retrieve each line in the file. Now to get each line in the file, you can use a read lines method to return a list in which the element is a line of the file. So here it works in the same way. Now you can also use the for loop to iterate through the lines in the file. So if you want to check the lines in a file, you can use the for loop. So for line in file. So this is how it's going to work. In the output, the lines are separated by blank lines as the print functions automatically adds a new line at the end of its output. Now, if the file has 7 lines of content, what will the following expression return? It's going to return 7 of those lines. Next, we have the writing of the files. Now, to write the files, you can use the write method, which writes a string to the file. Now, this has been written to a file, and this adds in the file, the new file. The write mode will create a file if it does not already exist. Now, which line of code writes hello world to a file? When a file is opened in the write mode, the file's existing content is deleted. which means that you're starting the writing of the file from the very first. Now, as you can see, the content of the file has been overwritten. What happens if you open a file in the write mode and then immediately close it? I think the file contents are deleted, because if you open it, the contents are deleted. The write method returns the number of bytes written to a file if successful. Now, if the working of the whole write method works properly, then it is going to just write the number of bytes. Now, to write something other than a string, it needs to be converted to a string first. So you need to do all this. If a file write operation is successful, which of the following statements will be true? File.write message is equal to len message. So let's just see. File.write. Going to print all the number of bytes in that particular file. Now we have the last from this lesson, which is working with files. So it's good to practice to avoid wasting resources by making sure that files are always closed after they have been used. One of the way of doing this is try and find. Try opening it, and whatever is done after that file should finally close. So f dot close. Now this ensures that the file is closed even if errors occur, so that the file is safe. Now f is equal to open file name dot text print f read and print 1 by 0. So will the close function get called in this? Yes, because as we've seen, even if an error occurs, like as it is occurring here, the closing of the file is done. An alternative way of doing this is with the use of the with statement. This creates a temporary variable often called f, and which is only accessible to the intended block of the with statement. With open file as f print f.read. So the file is automatically closed at the end of the with statement, even if exceptions occur. This is just for the security of the file. So with open as f print f.read. So yeah guys, that's all for today's video. If you like the video, just like, share, subscribe, comment down below and press the notification bell. Also make sure that you're following me on my Instagram, plus you've subscribed my channel.